Hi, my name is Jenna Hong, and I'm a senior at MIT studying brain and cognitive sciences and computer science and engineering. And my project is about enhancing human memory using augmented reality. I'm really interested in reverse engineering the science of intelligence to better understand abstract concepts such as causal and moral reasoning, and intuitive psychology and common sense understanding, which are all things that we use to better digest and process the world around us. Here at the Genesis Group in CSAIL, we believe that human intelligence is unique in our natural capabilities to tell and understand stories. I think it's really interesting to study how memory and learning play a key role in this very human storytelling. And so I base my research off of various neuroscience studies at MIT that elucidate how memory works in patients of Alzheimer's disease. So forms of dementia take the ability to access and retrieve memories away, but we can still encode and store them in the brain just fine. And so I study the moment where computers can help model and augment our very natural learning processes. I do my research in the media lab, in the fluid interfaces group, where we're working on building a multimodal augmented reality system that digitalizes something called the memory palace, which actually dates back to ancient Greek philosophy. The memory palace leverages imagination. By visualizing a space or a location that you know very well, and using mental images or visuals and associating them on particular points on the path, you can better consolidate these memories in your brain just by rewalking the path, mentally or physically. As it turns out, spatial navigation and episodic memory both rely on the same area of your brain, the hippocampus, and so I use audiovisual sensory cues to trigger neural firing in the hippocampus to better consolidate these memories through space. And the results have been really promising. Over the past year, I've been carrying out a series of human behavioral experiments, and it shows that the paradigm, which I call memory lane, shows significant improvement in retention in both short-term memory and long-term memory. By showing that sensory cues can actually help us encode memories in our brain better, we show that artificial intelligence can help us both understand human cognition, but also unlock further innovations in assistive mixed reality. And so I hope that this interface can serve as a good first step in empowering people to overcome learning barriers and memory impairments.